So the first lesson will deal with Roman numerals and standard measurements. We'll start off with Roman numerals. Most people are familiar with Roman numerals, at least 1 through 10. We know that I represents a single digit, so I represents 1, 2 I's represent 2, 3 I's represent 3. And the main three that people are probably familiar with are I, V, and X. V meaning 5, X meaning 10. The ones that people aren't so familiar with are probably in this section over here. Half is represented by 2 lowercase s's, so SS. And then these ones you've probably seen like Super Bowls and movie credits, things like that. L, C, D, and M. Okay, so L is 50, C is 100, D is 500, and M is 1,000. A good mnemonic device to use to remember that is lonely cows drink milk. Keeps it in the same order. The increments you just are going to have to memorize are 50, 100, 500, and 1,000. Rules. Now there are certain rules because you'll notice if we're looking at, for example, 4 or 9, those look a little bit funny, okay? And we'll get to that in just a second. So the rules with Roman numerals are we always want to use the biggest numeral possible. So for example, with 5, we'd want to use a V because you only have to write it once as opposed to putting 5 I's. We always go left to right in descending order, so you put the biggest numbers first. So 2 X's to represent 20, and then a V for 5, and then an I for the 1 to get the 6. A smaller number to the left means that it's being subtracted from the number to the right. So this is important. If you're looking and you come across and you see, okay, an I next to an X. Okay, well, we know I is smaller than X, so what that means is we're going to be taking I away from X, which is 1 subtracted from 10. So 10 minus 1 equals 9. Or VL, we know V represents 5, and L in our lonely cows drink milk represents 50. So 5 has to be subtracted from 50, which gives us 45. Okay. So writing, if you see this Hindu Arabic numbers, it means normal numbers. So write the Roman numerals as Hindu Arabic, aka normal numbers. So if we're looking, you could break it down. You see that the X represents 10, and then we have 2 I's, so that means each one represents 1. So 10 plus 1 plus 1 gives us 12. And the next one, we have 2 10s, so X and X is 2 10s, and then we have a V, which is a 5, and then an SS is a half. So 10 plus 10 plus 5 is 25, and then that, we just keep the half there. XL, okay, so here's our first case where we know X is 10, but L from our lonely cows drink milk, we know that L represents 50. So that means we're going to have to take 10 away from 50. So 50 subtract 10 gives us 40. And over here, we have, again, right away we can see that we have an I coming before an X, so we know we're going to have to take that I away from that X. But these 2 X's up front, they're okay. We just add them. Each X is 10, so 10 plus 10. And then we're going to have to add this last piece where we take the I away from X, so we're taking 1 away from 10. So 10 plus 10 is 20, and then 10 minus 1 is 9, so that gives us 29. Try another one. So if we had L, X, 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 I, X, first thing you want to do is look and see if there's any cases where you have smaller numbers and that you're going to have to take away from. So right here, we know I coming before an X, we know that's going to be 9. So that's something to keep in mind, but L is bigger than x, so we know we're okay just going in our normal order. So we know L is 50, and then 3x's means adding 10 3 times. And this is how you would show your work, just in case, because you always want to show your work. If you just write your final answer and it's wrong, then you don't get any marks. But if you show your work and you've at least done a step or two correctly, then you can get part marks. So always show your work. And then I minus x, so that's, we're going to take the 1 away from the 10. And 50 plus 10 plus 10 plus 10 is 80, and then the 9 gives us 89. All right. So flipping that on its head, we can go the other way, right? So right as Roman numerals, you could be given normal, quote, normal numbers, Hindu-Arabic numbers, and we have to write those as Roman numerals. So we know that 17, what you want to do is break it down into the increments of Roman numerals. So if we look at Roman numerals, we have 1s, which are the I's, we have V's, which are the 5s, and we have X's, which are, X's, which are the 10s, and then we have our lonely cows drink milk. Okay, so coming back here, we want to break this 17. Well, we can break that down into a 10, and then there's also, that leaves us with 7. So if we take a 5 out of that, and then we have 2 left over. Okay, so now we know 10s are X's, 5s are V's, and 2s are I's, so we need 2 I's, and you get XVII. Okay, 120. So we know we have 100, which is in our lonely cows drink milk. That's represented by a C. And then we have 20, which is just 2 10s. Okay, so C for the 100, and then each 10 is an X, so we have CXX. Okay, now this is probably the trickiest part with Roman numerals is if we know we have 400 here with this 419, and then we have a 10, and then we have a 5, and then we have 4, if we break it down. Okay, so writing 400, you could write it with 4 C's going back here, but remember our rules down here that use the biggest numeral possible, and you want to use, essentially you want to try and use as few Roman numerals as possible. So writing 4 C's for 400, that would mean we would have 4 C's. But if we use our rule about the smaller number to the left, then we would only have to use 2 digits for the Roman numerals. So we could just say, well, we know that 400 is equivalent to 500 take away 100. So if we put a C before the D, that would really shorten our numeral. So let's use that. So we'll use 100 taken away from 500, so that's CD. And then with our 10s, 10 is an X. And then again, I wrote 5 and 4, which I was just testing you. That would have been 4 I's, whereas we know if we write 9, then we can just put that as an IX. Okay? So 24 and a half, we'll break that down. That's 2 10s. And then a 4, which can be written as IV as opposed to 4 I's. And then we have a half. Okay? So we know 10 is X, 10 is X, 4 is 1 taken away from 5, and the half is SS. Right? So with Roman numerals, it really just takes some practice getting used to the numbers and what they mean in that rule about subtracting 1. But the key with Roman numerals is always look for a case where you have a smaller number, a letter that represents a smaller number in front of a bigger one. Okay, so that as long as you know the order going back up here, especially with the lonely cows drink milk, as long as you know that order, that will really make things a lot easier, because that'll trigger something, hopefully, for you to recognize, okay, there's an operation happening there. Okay, standard measurements are used a lot in hospitals and doctors' offices and things like that. And because when you have patients, you want to make sure that you want to measure their food and fluid intake, and you want to first of all, you want to make sure that they're staying hydrated. So you want to make sure that their output with fluids is not greater than their input. And you'll see this a lot throughout through the course is cc's, or cubic centimeters. The textbook is American, so it's important to recognize when you are in field in Canada, we use milliliters, but 1 cubic centimeter is equivalent to 1 milliliter. And then you have other estimation guides about how how they measure intake. So just for fluids, ounces are equivalent to 30 cc's or 30 mils. Carton of milk, 240, juice cartons, cups of Jello, ice creams, popsicles, and so on and so forth. Okay. So Mrs. Pierce had 1 bowl of soup, 1 6-ounce coffee, and an 8-ounce glass of water for lunch. What was her total intake in cc's? So she had soup, she had coffee, and she had water. Okay. Now for the soup, she had 1 bowl of soup. So go back to our chart. 1 bowl of soup is 150 cc's. So we'll just write that down over here, give us some space. Okay. A coffee. Okay, she had a 6-ounce coffee. So on our chart, coffee's not in our chart, but remember fluids are measured in ounces. So 1 ounce equals 30 cc's. So then if she had 6 ounces times 30 cc's, that's 180 cc's. Okay, and then for water, she had 8 ounces of water. So 8 ounces times 30 cc's, just like with the coffee, each ounce is worth 30 cc's. That gives us 240 cc's. Now, whenever you're looking at a word problem, always look at the question to make sure you know what you're looking for, okay? So what was her total intake in cc's? So if we're looking at a total, then what we're going to have to do is add up all the cc's that she took in. So if we add those up, adding up the columns, the 0 column, and in this first chapter especially, you won't be allowed to use a calculator, and in many nursing programs you can't use calculators, so we have to work on those basic numeracy skills. So we add up the first column, and they're all zeros, so 0 plus 0 plus 0 is 0. And now the next column, 5 plus 8 is 13, plus 4 is 17. We carry a 1 up here, and now the 1 plus 1 is 2, plus 1 is 3, plus 2 is 5. So Mrs. Pierce's total intake was 570 cc's. All right, next question. So determine this patient's fluid balance or imbalance. So they would have given us, you'll be given certain information. It's important to write that down. But they gave us the output, and if it's a fluid output, it's going to be in urine. And now what we have to do is they'll tell us what the patient ate in their intake, but we need to measure it in cc's or in mils. So the output was measured in mils, so that's the same as 1745 cc's. Okay. So 3 cups of Jello, if we go back to our chart, 1 cup of Jello is equivalent to 120 cc's. So 3 cups of Jello is going to be 3 times 120 cc's, which gives us 360 cc's. Okay, 4 cups of water at 8 ounces. So this is saying each water is 8 ounces. So we have 4 times 8 ounces equals 32 ounces, and each ounce is worth 30 cc's. So 32 ounces times 30 cc's gives us 960 cc's. Same thing, 6 ounces per ginger ale. So, and the patient had 2 ginger ales, so 2 times 6 gives us 12 ounces, and each ounce is worth 30, so we multiply by 30, and that gives us 360 cc's. Okay, and then 1 popsicle, this one is on the chart. Popsicles are worth 90 cc's. So 90 cc's. So now what we have to do is figure out her total intake. So adding up the columns, 0 plus 0 plus 0 plus 0 plus 0 gives us 0. 6 plus 6 is 12, so we're going 6. Next column, I didn't line these up very well, but 6 plus 6 is 12, plus 6 is 18, plus 9 is 27. And then in the last column, we're going to go 2 plus 3 is 5, plus 9 is 14, plus 3 is 17, plus 9 is 17. Sorry. So 9 plus 3, this 9 doesn't have has no third digit. This 9 was calculated in the second digit. So anyway, 2 plus 3 is 5, plus 9 is 14, plus 3 is 17. So this patient's intake was 1,770 cc's. And we know, again, going back, determine this patient's fluid balance. So fluid balance, it's like your bank balance. It's just what comes in and what goes out. So you want to have the intake minus the output. So if her intake was 1,770 and the output was 1,745, okay, so 0 take away 5, can't do that, so we have to borrow from the next one over. That becomes a 6, and now we have 10 minus 5 is 5, 6 minus 4 is 2, 7 minus 7 is 0, and 1 minus 1 is 0. So her overall fluid retention is 25 cubic centimeters or 25 milliliters, whichever one they ask for. Okay. Last example, a pharmacy tries to maintain, minimum inventory of 250 tablets of a certain medication. At the end of the day, there are 30 tablets left. How many bottles must be ordered if the medication comes in bottles of 60? So this is a multiple step problem. And remember, you always want to look at, the question is how many bottles must be ordered? Okay, that's what we're trying to get to. Okay, so first of all, they keep their minimum tablets on hand. They keep track of that in tablets, not in bottles. So they want a minimum of 250 tablets. But at the end of the day, there's only 30 tablets left. So we got to find out the difference between what they want and what they have. So when you're doing a difference, you subtract. So we say they wanted 250 tablets, but there's 30 left, so that means that they're going to need the difference. So 0 minus 0 is 0, 5 minus 3 is 2, and 2 minus 0 is 2. So they need 220 tablets. Okay? Now, the medication comes in bottles of 60. So say you have and we need 220 tablets, right? So say these are your tablets, and say there's 220 of them. We need to divide them up into groups of 60 so that we know how many bottles we need, right? So if the green represents the bottles, so obviously that means we're going to be dividing. So we're going to be dividing 220 by 60 because there's 60 tablets per bottle. Okay, now the 60 doesn't go into the doesn't go into 2, so we move over, and 60 doesn't go into 22 either, so we move over to the next one, and 60 does go into 220, and it goes 3 times. Okay, so now we go 3 times the 60, so 3 times 0 is 0, and then 3 times 6 is 18. So that gives us 180, and now we subtract. 0 minus 0 is 0. 2 minus 8 we have to borrow, so that becomes a 1, and now we have 12 minus 8 is 4, and 1 minus 1 is 0. Okay, so we have 3, but we have 40 left over, so that means we're going to have to add a decimal, add a 0, and bring it down because 60 does not go into 40. Okay, so we bring down the 0, and 60 will go into 400, and it goes in 6 times. So 6 times 0 is 0, and 6 times 6 is 36, and then 0 minus 0 is 0. 0 minus 6 doesn't work, so we have to borrow, so that becomes a 3, and that turns into a 1. So 10 minus 6 is 40, 3 minus 3 is 0. And this is going to keep going on, because if we just keep adding zeros, you're going to get the same thing as 400 minus 360, so you're going to get 66. So let's just round that off to 3.67. So that's how many bottles we need, right? But the question is, do we want 3 or 4 bottles, right? Because you can't walk into a pharmacy and ask for 3.67 bottles of aspirin or something like that. Okay. Well, if we know each bottle has 60 tablets, 3 times 60 gives us 180. 4 times 60 gives us 240. So we know that we need 220 tablets. So the 3 doesn't meet our minimum requirement. The 4 would. So therefore, so you'll see these dots a lot, and this is how you should put your final answers. Therefore, 4 bottles must be ordered. Okay, so it's a little bit of, it's math that you're all familiar with. You've done at some point. The Roman numerals, maybe not as much, but the more practice you do, the better you'll get at it. So just have a go, and if you have instructions, talk to your instructor.